Welcome to Tomorrow Unveiled.
It's great to be here.
I was looking at the calendar just before we started recording today. It is the last week of January 2026.
Already.
Right. And usually when we sit down to go through the research stack for Tomorrow Unveiled, we're looking at a collection of stories that feel... well, they feel evolutionary. You know what I mean? A chip is maybe 10% faster. A software update makes a button blue instead of green. It all just feels gradual.
Right. Iterative. That's the standard pace of technology. Slow and steady.
Exactly. But looking at the stack of research for this week, it feels like the history books are going to put a bookmark right here.
Yeah.
We aren't just looking at cool tech anymore. This feels like a massive structural inflection point.
I think inflection point is really the only way you can describe it. And if you look at the data our research team pulled, specifically comparing this January to last January, the shift is it's undeniable.
How so?
We're moving from what we're calling the experimental era of robotics, which was all defined by those viral videos. The parkour, the backflips, showing off what the hardware could do in a lab. We're moving from that into the deployment era.
And that distinction, that's crucial, because deployment sounds boring.
It does.
It sounds like logistics. It sounds like spreadsheets and efficiency reports.
It is boring, and that is exactly why it matters so much. Deployment is all about reliability.
Right.
It's about supply chains. It's about the cold, hard economics of labor versus capital. The question is no longer, can the robot do a jump?
No.
It's, can the robot show up for a 12-hour shift without falling over, and does it cost less than the human standing next to it? That's the real test.
And the scope of this convergence is what really struck me. We are not talking about one startup in a Silicon Valley garage.
No, not at all.
We are seeing a collision of three absolutely massive industries: heavy industrial manufacturing, the absolute cutting edge of generative AI, and advanced bipedal mechanics.
And the money, the capital flows, they reflect that completely.
Just to ground us in the numbers before we get into the specific companies.
Please.
Our research team flagged a market report that was referenced this week. They're projecting the robotics market to jump from roughly $51.5 billion in 2025
Okay, so last year?
to nearly $200 billion by 2035.
Wait, $200 billion? That's a four-fold increase in a decade.
A four-fold increase. That is a massive injection of value into an industry.
That is just massive.
It signals that the market believes this isn't a fad. This is a fundamental shift. We're seeing this move toward what Jensen Huang at NVIDIA keeps calling physical AI.
Physical AI. I want to stick on that term for a second because we hear AI thrown around for everything. How is this different from the AI we're all used to?
Well, until now, most AI has been disembodied. It lives on a server somewhere.
In the cloud.
Exactly. It processes text or pixels, it gives you a recipe, or it generates an image of an astronaut riding a horse. Physical AI is intelligence that has to deal with gravity.
It has to deal with friction, with spilled coffee, with the chaotic, unpredictable nature of the real world.
So our mission for Tomorrow Unveiled today is to really unpack that, to figure out, is the technology actually ready for that reality?
Exactly. Or are we just looking at some very expensive, very smart paperweights?
Well, to answer that, I think we have to start with this story that legitimately shocked the entire automotive industry this week. And that's Tesla.
Tesla pivot, yeah.
And I want to be really precise here because we're not just talking about a new product line.
Right.
We are talking about the honorable discharge, as they called it, of the Model S and the Model X.
The cars that built the brand, the icons.
These are the cars. The Model S is the reason electric cars are cool. It's the car that started the whole revolution. And this week, Tesla effectively said, we're done.
It's just, production ends by the second quarter of 2026. Full stop.
It really is the end of an automotive era.
It is, but you have to peel back the why. They aren't shutting down these lines because the cars aren't good, or even just to save a little cost.
Right.
They are clearing the floor at the Fremont factory, one of the most famous auto plants in the world, specifically to make room for Optimus robot production.
See, that's the part that just feels like such an incredible gamble to me. They are taking their flagship vehicle capability, the thing that generates their actual, revenue.
The profit center.
And they're ripping it out to build a robot factory.
It's a burn the ships moment. It's a statement. And the stated goal is targeting an annual production of 1 million humanoid units.
1 million units.
1 million. Now, just pause on that scale for a second.
Okay.
Most robotics companies, I mean, the really successful ones, they are thrilled if they can manufacture maybe 100 units a year.
100.
100. Tesla is tooling up for 1 million. It signals that internally they believe the future valuation of the company isn't in selling luxury sedans anymore.
It's in selling labor.
It's in selling automated physical labor.
But is that realistic? I mean, it really feels like selling your house to buy a lottery ticket. Where is the robot actually at today? Is it ready to replace the car?
That is the right question. And this is where we have to apply some heavy skepticism. Our research team dug into the earnings calls and some of the internal memos that leaked this week.
Okay.
The Tesla AI team is bracing for what they are internally calling their hardest year yet in 2026.
Why hard? I mean, if they're building the factory, shouldn't they be confident? That sounds like they're on the home stretch.
You would think so, wouldn't you?
Yeah.
But Elon Musk admitted on the recent earnings call that, and I want to be really accurate here, no Optimus robots are currently doing useful work in the factories yet.
Wait. None. Zero. Because I have seen the videos. I've seen them sorting battery cells. I've seen them walking around the lab pretty confidently.
You have seen demonstrations. And there is a massive, massive gap between a robot that can sort a battery cell for a 30-second video on X and a robot that can stand on a production line for 8 hours, handle edge cases, recharge itself, and not slow down the human workers.
So that's the gap they haven't closed yet.
That is the chasm they haven't closed yet.
So they are building a factory for 1 million robots, but the robot itself can't technically hold down a job yet.
That is the friction of the inflection point we're talking about. The hardware is getting ready. The brain is still lagging behind. Let's look at the specs for the Gen 2 and Gen 3 Optimus that were detailed this week.
Okay, yeah, let's break it down.
The form factor is basically settled. It is 5'8", weighs about 57 kilograms.
So 125 pounds, very human-like.
Exactly. And it moves at about 8 kilometers per hour.
Which is a brisk walk, a light jog maybe.
A brisk walk, yeah. But the critical update, and this is where the engineering really gets impressive, is the hands. The Gen 3 hands have 22 degrees of freedom.
We hear that term a lot in robotics, degrees of freedom. Can you break that down for someone who's not an engineer? Why does 22 matter?
Sure. Think of a degree of freedom as a single way a joint can move.
Okay.
Your elbow has 1 degree of freedom. It bends and straightens. That's it. Your shoulder, though, it has 3. It can go up, down, forward, back, and it can rotate.
Right, I see.
The human hand is incredibly complex. It's a marvel. 22 degrees of freedom in a robotic hand means it has roughly human-level dexterity. It isn't just a simple claw opening and closing.
So it can, articulate its fingers individually?
It can articulate fingers. It can wrap its palm around a tool handle. It can pinch a delicate wire with a thumb and forefinger.
So it's designed to use our tools in our world.
Exactly. And that is the holy grail of general-purpose robotics. If you build a robot with a specialized claw, you have to redesign the entire factory to fit the robot.
Right.
But if you build a robot with human-like hands, you can theoretically just drop it into a factory that was built for humans.
But, and I feel like there's a big but coming.
Here is the catch. Having the hand is one thing. Having the software brain to control all 22 of those degrees of freedom simultaneously without crushing the object you're trying to pick up.
That's the hard part.
That is exponentially harder.
It's like giving a Stradivarius violin to a toddler. The hardware is exquisite, but the output is, well, it's just noise.
Precisely. That is the perfect analogy. Tesla is betting the farm on the manufacturing scale, making the violins, assuming the software, the brain, the musician, will catch up in time to fill those robot bodies with competence.
And speaking of, ambitious timelines, we can't ignore the Mars angle.
The Mars angle, yes.
Musk announced plans this week to send an Optimus robot to Mars aboard a Starship in 2026.
This year.
This year. I mean, this feels like a PR stunt, doesn't it? Is this just to generate hype?
Well, it absolutely sounds like science fiction or, just pure hype generation.
Yeah.
But if you strip away the spectacle and look at it from a pure engineering perspective, it's actually the ultimate validation test.
How so? What does Mars prove that a factory in Fremont doesn't?
Because Mars is the ultimate unstructured environment. In a factory, you know where the floor is. It's flat. You know the lighting conditions. You know the temperature.
It's controlled.
It's a controlled environment on Mars. It's dust. It's radiation. It's uneven, rocky terrain. It's extreme temperature swings. If you want to prove your robot is truly general purpose, meaning it can handle anything you throw at it.
And you throw a planet at it.
You send it to operate where humans literally cannot survive without a suit and a habitat. That sets the bar about as high as you can possibly set it.
Right. If it can fix a heat shield on Mars, it can definitely fold my laundry.
Or fix a leak in a nuclear reactor. Or work in a deep-sea oil rig. It's incredibly high stakes, but it aligns with the broader mission. However,
go on.
While Tesla is making these huge strategic pivots and, dealing with their hardest year, they are not the only ones in this game. And in some very important ways, they aren't even the ones winning the deployment race right now.
That is a perfect segue, because while Tesla is busy clearing out the factory floor, other companies are actually shipping units to paying customers. Let's talk about Figure AI. We have been tracking them for a while on Tomorrow Unveiled.
Figure is fascinating because they are moving incredibly fast on the infrastructure side of things.
What do you mean by infrastructure?
They aren't just building a robot in a lab. They announced a dedicated, large-scale manufacturing facility they're calling BotQ.
BotQ. It sounds a little bit dystopian, honestly.
It does have a certain sci-fi ring to it, doesn't it? But functionally, it's a factory designed from the ground up to churn out their Figure 03 and their newer Helix models.
And the distinction with Figure, or what I've seen, is the versatility in their demos. It's not just factory work.
Not at all. We have seen the Helix models specifically being demonstrated on domestic tasks. Folding laundry, loading dishwashers, making coffee.
See, that is the use case I really care about. I don't need a robot on Mars. I need a robot to empty the dishwasher, because it is the one chore I fundamentally despise.
And that is the domestic grail. That's the billion robot market right there. But before we get to the home, we have to look at the boring work that's actually paying the bills for this industry.
And that brings us to Agility Robotics.
Agility Robotics.
Right. They make Digit, the one with the backward bending knees.
Yes, the digitigrade legs. It looks a bit bird-like. It's designed specifically for logistics, picking up boxes, moving totes in a warehouse.
And they hit a massive milestone this week that I think flew under the radar for most people, but in the logistics world, it's huge.
It's absolutely huge. Digit has now officially moved over 100,000 totes in commercial deployments.
100,000 totes.
100,000. And to be clear, that is not a demo.
Yeah.
That is not a simulation. That is 100,000 plastic bins moved from point A to point B in a real functioning warehouse for a real customer.
And we can guess who that customer is.
Given their deep partnership history, it's very likely Amazon.
That is the difference between the experimental era and the deployment era right there, isn't it?
Yeah.
One is a cool video, the other is a line item on a balance sheet.
Exactly. Agility is proving that you don't need to be perfectly human-shaped to do valuable work. You just need to be reliable and cost-effective.
But then we have to talk about the biggest barrier to entry for all of this, and that's price.
The price tag.
Because usually when we talk about these advanced humanoids, we're assuming they cost as much as a luxury car or a small house.
Right.
Tesla has floated numbers like $25,000 eventually, but that's years away.
That's the aspirational price.
Right. But then comes Unitree from China.
The Unitree G1. This is the market disruption.
The price point they announced is roughly $16,000 starting price.
$16,000. That's roughly the price of a used Honda Civic.
For a fully articulated humanoid robot, how is that even physically possible? I mean, the specialized motors alone usually cost more than that.
It comes down to China's complete dominance of the supply chain and their expertise in vertical integration.
So they make everything in-house.
They control the rare earth magnet supply for the motors. They control the battery chemistry, the electronics manufacturing, the assembly. Unitree is leveraging that entire ecosystem.
Okay, so what are the specs on the G1?
The G1 is a bit smaller. It's about 127 centimeters, so roughly 4'2", but it's fast, 12 kilometers per hour.
Faster than Optimus.
Faster than Optimus. And it has extremely high dexterity, boasting 43 degrees of freedom.
43! That's almost double what Tesla has. So it's smaller, faster, more dexterous, and half the price of what Tesla is even promising in the future.
On paper, yes. It is an absolutely incredible piece of engineering value, but...
There's always a but.
There's always a but.
And let me guess, it's not about the hardware. The hardware sounds amazing.
It's about the software and, more importantly, the security. If you're an enterprise client, a hospital, or even just a privacy-conscious homeowner, buying a robot is very different from buying a toaster.
It's not a dumb appliance.
It is a device with multiple high-definition cameras, microphones, and a continuous internet connection that is actively mapping the inside of your secure facility or your home.
And our research team found some specific reports about that, didn't they?
They did. There are several credible reports flagging potential backdoor vulnerabilities in the software stack. And perhaps more significantly, there is a U.S. congressional investigation currently underway looking into potential ties with the PLA, the People's Liberation Army.
So the fear is you can have a cheap, highly capable robot, but it might be phoning home to Beijing with a 3D map of your living room or your factory floor.
That is the concern being raised. It creates this classic trade-off, accessibility versus security. If you are a defense contractor in the Midwest, you are probably not buying the G1, no matter how cheap it is.
That is going to be a huge geopolitical debate moving forward. I can see it now. But speaking of homeowners, there's another player taking a very, very different approach to getting into our homes, and that's 1X Technologies.
1X is interesting. They have two main robots, the NEO for households and the EVE for the workforce.
And they just signed a huge deal.
A massive partnership with EQT to roll out 10,000 units. But the detail in the announcement that really caught my eye was the catch for the early adopters of the home robot.
There's a catch. What is it?
One of the sources our team found mentioned that the NEO robot launches with a specific condition. It needs the human owner to actually do the chores initially, or at least guide the robot through them using teleoperation.
Wait, hold on. I buy the $1,000 robot, but I still have to do the chores.
You are effectively piloting the robot to train its AI. You are buying the privilege of being a data labeler for the company.
That's diabolical. And brilliant.
It's absolutely brilliant. Think about it. Why is home robotics so incredibly hard?
Because every home is different.
Every home is different. Your dishwasher handle is different from mine. Your socks are folded differently. The lighting in your kitchen is unique. 1X is solving this massive data problem by outsourcing the training directly to the customer.
So they're building a proprietary data set.
A massive proprietary data set of household physics that no one else in the world has.
So you're paying them to be the teacher for their AI.
In a sense, yes. But the promise is that eventually, after you've taught it, the robot learns, and then it does the chore for you forever.
So let's zoom out for a second. We have the bodies being built by Tesla and Figure. We've got this immense price pressure coming from Unitree. We have the clever training model from 1X. But you mentioned earlier the brain problem. The hardware is still ahead of the software.
It is. But that gap is closing, and it's closing fast. And that brings us to the physical AI breakthrough we mentioned at the top of the show.
Okay, explain physical AI again. How is it different from, say, ChatGPT, which everyone knows?
ChatGPT is a large language model. Its entire world is text. It's incredibly powerful, but its job is to predict the next word in a sentence. Physical AI involves what are called vision language action models. It doesn't just predict the next word. It has to predict the next movement in a physical space. It has to understand that if it drops a glass, the glass breaks. There are consequences.
So how do they learn that? Do they just let the robot fall over 1,000,000 times in the lab? That seems expensive.
If they did that, they would go bankrupt, just repairing the robots. The answer is a technique called sim-to-real.
Sim-to-real.
Imagine a hyper-realistic video game, a simulation. NVIDIA has a platform called Isaac Sim. In this simulation, the robot can try to pick up a cup or walk over a pile of rocks millions and millions of times in just a few minutes.
But it can fail safely.
It can fall, it can break, it can fail, and it can retry instantly without costing a single cent. It learns the laws of physics inside the matrix, essentially.
And then what? You just download that knowledge.
You download that muscle memory into the physical robot, and usually it works surprisingly well. But there has always been a missing sense for these robots. Robots are, for the most part, numb.
Numb? What do you mean?
They rely almost entirely on vision. They see the cup, they calculate the distance, and they close their gripper. But if the cup is slippery from condensation, or if it's a flimsy plastic cup and they're about to crush it, the robot doesn't feel it.
Which is why we see so many videos of robots accidentally crushing things.
Exactly. This week, Microsoft dropped an absolute bombshell in this space with a new model they're calling Row Alpha.
Row Alpha.
It's a vision language action model. But the key differentiator, the game changer, is tactile sensing. It incorporates touch data into the decision-making loop.
So it basically gives the robot a sense of touch. It gives it nerves.
Effectively, yes. The research our team looked at noted that this model improves dramatically with human feedback. So imagine a robot trying to do something difficult, like inserting a plug into a wall socket.
That's surprisingly hard for a robot.
It's incredibly hard because of the precise force and alignment required. If the robot fails, a human can take control via teleoperation, sort of wiggle the plug in, and the model learns from that feeling of resistance and then the final release.
That is the missing link. I mean, just try tying your shoelaces with numb fingers. It's impossible.
You can't do it. Vision isn't enough for fine manipulation. Microsoft adding this tactile layer is a huge step toward robots that can actually do useful, delicate work. And NVIDIA's right there with them, too.
Right, with their own model.
With their GR0T and Cosmos models, which are trying to give robots a general, foundational understanding of the world.
Jensen Huang had a specific pitch about this recently, didn't he?
He did. He was speaking at Davos, and he was specifically addressing the leaders of Europe. His argument was fascinating. He basically said, look, Europe, you kind of missed the software wave. The U.S. won the internet.
Okay, a bit blunt.
But he continued, but Europe has the factories. Europe has the massive industrial base. Siemens, BMW, Mercedes, all of them.
So his pitch is, use your factories to win the race for physical AI.
Exactly. It's a revenge of the old economy argument.
Yeah.
He's saying that in this new world of physical AI, knowing how to build a complex Mercedes transmission is just as valuable as knowing how to code a neural network.
We are going to take a quick break in just a second, but it really does feel like all the pieces are finally falling into place. You have got the bodies, you've got the brains, and now you have the touch.
The convergence is very real.
Before we move on to the robots that aren't human-shaped, because our research team found some wild ones this week, I just want to take a moment for everyone tuning in.
Yes, please do.
If you're finding this insightful and you're watching on YouTube, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers.
It really does help the algorithm find people who are curious about this stuff.
It does. And of course, be sure to turn on notifications so you never miss an update on the future.
And for our audio listeners.
Yes, if you're listening on a podcast service like Apple Podcasts or Spotify, we would be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners.
And we do read every single one of them.
We absolutely do. Okay, let's pivot. We have been talking a lot about humanoids. 2 legs, 2 arms, looks like us. But some of the most impactful news this week came from machines that look nothing like us at all.
That's right. While the humanoids get the headlines because they look like something out of sci-fi, specialized robots are quietly taking over entire specific verticals.
Let's start with construction. Doosan Bobcat unveiled something called the RX-3 Autonomous Concept Loader.
The RX-3, yes.
I saw the pictures of this thing, and the very first thing you notice is what is missing. There's no cab, there's no place for a person to sit.
No seat, no steering wheel, no glass.
Then I want to unpack why that is so much more important than it sounds. Is it just about saving the cost of the glass in the seat?
Oh, it's much, much more than that. It's a fundamental design philosophy shift. For 100 years, all heavy equipment has been designed around a human driver.
Right.
And that imposes huge constraints. You need a line of sight, so the engine has to be in the back. You need a heavy roll cage for safety. You need a complex suspension just to keep the human from getting sick.
So when you take the human out of the equation, what happens to the machine itself?
You change the entire geometry. The RX-3 has this wild, deformable construction for rough terrain. It has independent tracks. It allows for a much lower center of gravity. It's smaller, it's lighter, and it's far more agile because it doesn't have to protect a fragile sack of meat inside it.
A fragile sack of meat.
It's true. Humans are the limiting design factor in a lot of heavy industry. Removing the cab unlocks the physics of the machine.
Speaking of humans being the limiting factor, let's talk about surgery. Because this number that our team found just blew me away. Neosis.
Neosis and their Yomi system. They just announced they have surpassed 100,000 osteotomies.
And an osteotomy it's cutting bone, right?
Specifically in dental surgery. It's for drilling into the jaw for dental implants.
100,000 times a robot has drilled into a human skull? I mean, that sounds terrifying on the surface, but you're telling me it's actually a massive safety milestone.
It is an incredible safety milestone, and it's a perfect example of what we call collaborative robotics.
So the robot isn't working alone?
No, the dentist doesn't just press a button, go for coffee. The dentist is holding the drill the entire time. But the robot provides what's called haptic guidance.
Haptic guidance? How does that work?
Think of it like a lane assist in your car, but for a high-speed drill aimed at your face.
Okay, that's a good visual.
The dentist plans the entire surgery on a computer beforehand, mapping exactly where the nerve is, exactly where the sinus cavity is. Then, during the surgery, the robot physically refuses to let the dentist color outside the lines.
So if the dentist's hand slips or they have a tremor, the robot actually fights back.
It provides resistance, it locks, it prevents the drill from going even a millimeter too deep or a millimeter too far to the left. It effectively eliminates human tremor.
So it makes an average surgeon good and a good surgeon perfect.
That's the idea. It isn't replacement, it is augmentation. That's the kind of robotics that's having a real-world impact today.
Okay, so we've done the ground, we've done the dentist chair. Let's look up at the sky. Because drone delivery, I feel like we have been hearing drone deliveries coming for at least 10 years now.
We have. It has been stuck in what the industry calls pilot purgatory for a very long time.
But this week, the tone felt really different.
It did. It moved from pilot project to full-scale infrastructure. Walmart and Wing announced they are expanding to 150 more stores.
And their coverage area.
They're going to cover 40 million Americans by the end of 2026.
40 million people. That is not a niche test market in a small town in Arizona. That is a significant chunk of the entire U.S. population.
It is. And it's not just them. Zipline is expanding into Houston and Phoenix. Lucent Bots is launching these Sherpa drones to pressure wash skyscrapers. We're even seeing the University of Oklahoma using drones to fly into storms to capture data. We're reaching the point where the sky is becoming an active industrial layer of our cities.
But, and here's the big but again, we have to talk about the bottleneck. Because if we have millions of humanoids in factories and tens of thousands of drones in the sky and robotic loaders on every construction site, we hit a very hard physical limit.
The Achilles heel of the entire robotics revolution.
Power.
Batteries.
Because right now, if I buy that $16,000 Unitree robot or even the future Tesla Optimus, how long does it actually run before it just dies?
The current state of the technology is deeply underwhelming. Most of these advanced humanoids, like Optimus or the Unitree models, they only last about 2 to 4 hours on a single charge.
That is it, 2 to 4 hours. That's not a full shift. That is barely a long morning meeting.
Exactly. You cannot run a 2147 factory if your workers have to go take a nap for 4 hours every 2 hours. It just doesn't work.
So how do we fix this? Because it seems like standard lithium-ion batteries are hitting a wall.
The fix, and this is where the entire battery industry is scrambling, is solid-state batteries.
We've heard a lot about these for electric vehicles. Why are they so crucial for robots specifically?
It's all about energy density and safety. Solid-state batteries can hold way more energy in the same amount of weight. Now, for a car, weight matters. But for a walking bipedal robot, weight is everything.
Because it has to lift itself with every step.
Every single ounce of battery is another ounce you have to carry, which burns more battery. It's this vicious cycle. Solid-state technology breaks that cycle.
What are the growth projections for this?
Our research team found a report predicting that demand for solid-state batteries specifically for robots will explode 1,500 times by 2035.
1,500. 1,500 times.
Reaching a demand of about 75 gigawatt hours. And this connects all the way back to the Tesla story. Why is a car company pivoting so hard to robots?
Because they already control the battery supply chain.
They control the batteries. XPeng, another car company, is doing the exact same thing with their robotics division. If you control the power source, you control the robot industry.
That makes so much sense. It isn't just about the AI. It is about the juice.
And it's about the infrastructure to deliver that juice.
Yeah.
Jensen Huang mentioned this too. Europe needs to solve its energy supply and infrastructure cost problem.
Yeah.
You cannot have a physical AI revolution if electricity is too expensive or the grid can't handle the load of millions of new machines plugging in.
There is one more bottleneck we need to discuss, and it's the one that, frankly, everyone asks about: safety and jobs.
Yes, the human element.
With these robots entering logistics, moving 100,000 totes, as you said, what happens to the people who used to move those totes?
There was a really interesting report from a trade publication, DC Velocity, this week that touched on this. The language in the industry is shifting. It's moving away from headcount reduction, which is the scary corporate speak for firing people, and moving toward outcome-driven automation.
What does that actually mean? Or is it just a nice-sounding euphemism?
It's a little bit of corporate spin, but there is a core of truth to it. It means focusing on automating the jobs that physically break people.
The back-breaking labor.
The back-breaking labor. Lifting heavy totes all day. Repetitive twisting motions in a factory. These are the jobs that cause chronic injuries that have incredibly high turnover rates because nobody wants to do them for very long.
So the argument is, let the robots take the jobs that hurt us.
Ideally, yes. But it creates a completely new dynamic. The robots aren't fully autonomous yet, as we discussed with Tesla's hardest year. They need managers. They need trainers. They need technicians.
So the warehouse worker becomes a robot shepherd.
In a way, yes. The job market shifts from lifting the box to fixing the robot that lifts the box, or teaching the robot how to hold the box better. It's a fundamental shift from physical labor to cognitive oversight.
But, and this is critical, that transition is messy.
It's incredibly messy. Not every person who lifts boxes can or wants to become a robot fixer overnight.
That's the friction point. That is the hardest year Tesla's talking about. It's not just hard for the engineers, it's going to be hard for the entire workforce.
It is. And the safety standards are still lagging way behind the technology. We don't really have a universal OSHA for humanoids yet. What happens if a 125-pound robot malfunctions next to a human on a production line? That is what the industry is trying to figure out right now, in real time.
It is a wild, wild time. Let's just try to recap this whirlwind of a week.
It has been a lot to process.
We have had Tesla literally killing their darling, iconic cars to build a robot army. We've had Microsoft giving those robots a sense of touch.
Yeah.
We have had drones getting approval to deliver dinner to 40 million people. And we have had Chinese competitors driving the price of a humanoid down to the cost of a used Civic.
The deployment era is undeniably here. It's messy, it's expensive, and the batteries aren't quite ready for prime time, but the machines are leaving the lab.
They are leaving the lab and they are entering the chat.
They really are.
So as we wrap up, I want to leave our listeners with a final thought based on what you said earlier about 1X Technologies. We talked about training these robots. We talked about 1X selling robots that we, the customers, have to teach.
Right.
And this is the final provocation for me. We are building these machines with the promise that they will work for us. That is the entire sales pitch. But right now, and probably for the next few years, with companies like 1X using early adopters as trainers, we might actually be working for them. Working for the robots.
We are teaching them how to fold our laundry. We are teaching them how to open our specific tricky doors. We are the teachers for a new species of worker. And once they learn that task from us and from millions of others, they won't need us to teach them anymore.
Wow.
So the question I'm left with is, are we ready to be the teachers? And more importantly, are we ready for what happens when the student finally graduates?
That is definitely something to chew on while you're loading your dishwasher tonight.
Or while you are patiently watching your robot try and fail to do it.
Exactly. We love hearing your thoughts. Whether you are on YouTube or your favorite podcast app, leave a comment and let us know what you think about the rise of the machines. Would you let a robot fold your laundry if you had to teach it how to do it first?
You know, I think I would. The long-term payoff is worth it.
I think I would too. Thanks for joining us on Tomorrow Unveiled.
See you next time.